Alright, we're going to continue where we left off in class here now. We have 3 more examples we want to do. Don't worry about the last 2 on the back of the page. We're just going to go 3 more. The 3 more on this page that we're at right now. Alright, so the next one we're going to look at is cosine of 2x plus 3 sine of x minus 2 equals 0. And it's going to be on the same interval as 0 is less than or equal to x is less than 2 pi. All right, so looking at this thing here, we have kind of the same issue that we have in the previous problem. All right, it's very, very similar to the last one, as in we have a cosine and we have a sine. Difference being the last one we had a square in there. But as I said in class, that presents a problem for us whenever we have two different trig functions. We have cosine and we also have sine. Especially in a world where we want to try to factor it, with factoring being the most efficient way to do this. One thing we could do, though, if we look at this, we have one value. It's a double angle right here with cosine of x. Then we have just a regular sine of x and then a constant. So if we could somehow get this into a sine squared of x, we're in good shape. And then we could factor it from there. Now looking at this, I can replace cosine of 2x, it's a double angle formula, to this. This would be from 2 lessons ago. 1 minus 2 sine squared of x. Okay, so then now the rest of it just tags along. Now I'm in an area where I can work with this now, because now I have my negative 2 sine squared of x plus my 3 sine of x, and 1 and negative 2 combine my like terms. I have negative 1. That's equal to 0. Okay, so now I have this in a polynomial form, a trinomial form. Okay, it would be a negative. So let's get rid of that negative real quick. Multiply everything by negative 1. Leave me a 2 sine squared x minus 3 sine of x plus 1 equals 0. If I want to factor this, it would be in the form 2x squared minus 3x plus 1. So that guy's going to factor to 2x minus 1 and x minus 1. So we can go ahead and just use that same concept just with the signs in it now. So now I have 2 sine of x minus 1 and sine of x minus 1. That's equal to 0. So now I can take both of these, each individual factor, set them equal to 0 based on our 0 property. So 2 sine of x minus 1 equals 0, and sine of x minus 1 equals 0. First one, add the 1 across, divide by 2. So I have sine of x is equal to 1/2. Second one, add the 1 across, sine of x equals 1. Okay, so we go back through, look around our unit circle, and we're going to have a couple places where sine of x is 1/2. It's going to be when x is pi over 6, and also at 5 pi over 6. And then I'm going to have the sine of x is equal to 1, and that's going to occur at pi over 2. All of those values fit within my 0 to 2 pi time frame, or 0 to 2 pi interval, so they're good. Okay. Next problem. Using more of our identity and formulas to rewrite these guys along the way. All right, so now this one we have sine of x cosine of x is equal to 1/2. And we're still 0 to 2 pi again. Okay, and then on there, I don't really like that 1/2 that we're equal to right now. So let's get rid of the fraction so I can multiply both sides by 2, see what that does for us. So 2 sine of x cosine of x equals 1. All right, that looks a little better. Now, I still have sine of x and cosine of x in the same thing. But if I remember my double angle formulas, this here is equal to sine of 2x. That's equal to 1. right, so now the sine of 2x is equal to 1. I have it just in one trig function. It's just in sine now. Now I have that multi-angle, kind of like we talked back in the second or third problem we did from this lesson. So this brings me to a point that I know when I'm at pi over 2, that's equal to 1. Okay, so I'm going to keep that same concept. At this time, though, I'm going to get 2x equals pi over 2, just like we did before, plus 2n pi. Okay, now we divide everything by 2. That's going to leave me with x equals pi over 4 and plus n over pi. Now again, I'd have to go back through and start plugging numbers in. If I plug in n equals 0, well, I get pi over 4. That one's good. Fits in the interval. If I go to n equals 1, plug that in, I'm going to have 1 1/4 or 5 pi over 4. If I put 2 pi in, as soon as I add 2 pi to something else, it's going to be over 2 pi. Therefore, these would be my two values for my x. Pi over 4 and 5 pi over 4. Alright, last one for this lesson. This one we're going to use sine of x minus cosine of x equals 1. And that's going to be for 0 is less than or equal to x is less than 2 pi. Same interval as we've been working with. Alright, again, I have a sine and a cosine here. Everything's in the first power, so there's nothing to factor. I can't really add or subtract anything across. I can't factor anything out, so I'm kind of a little bit in the pickle. What I want to do here, though, if I get this to somehow in powers and make a multiplication equal to 0, then I'd be all right. So what I'm going to do, I'm going to square both sides first. So I'm going to square both sides. So now, if I expand this out, square the first term, multiply the two together times 2, square the last term. That would be what I would the FOIL to. So now then, I have sine squared of x and cosine squared of x. Well, sine squared of x plus cosine squared of x, that's equal to 1 based off of our Pythagorean identity. So I have 1 minus 2 sine x cosine x. That's equal to 1. I like where this is going now, because now I subtract this 1 over. I have negative 2 sine of x cosine of x equals 0. Okay, this is looking pretty good. Now I can divide both sides by negative 2. I have sine of x times cosine of x is equal to 0. Doesn't look a whole lot different than what we started with. But when we started, we had sine x minus cosine x equals 1. But now we have everything written as factors and multiplication. So this brings us back to when we factor stuff. I can even put a pair of parentheses around there to make it look more normal. But if I have sine of x times cosine of x equal to 0, that means one of them is 0 or the other is 0. So I set them both equal to 0. Sine of x equals 0 and cosine x equals 0. Well, between 0 and 2 pi, there's 3 times that, actually 4 times, sine of x is 0 or cosine of x is 0. We're going to be at 0, at pi over 2, at pi, and at 3 pi over 2. Alright, sine of x would be 0 at 0 and pi. Cosine of x would be 0 at pi over 2 and 3 pi over 2. Alright, so there's the examples for that. So what you're going to do then is use these examples and use the notes as well as the last couple lessons that we've been working on and use that for your homework.